In section 3 of our factoring unit, we're going to look at some special case factoring. The first thing we're going to look at is difference of two squares. The difference of two squares is always a binomial that they're going to ask us to factor. Obviously it's a difference, so it's going to be subtraction of two perfect squares. So you kind of have to just recognize what you're dealing with when they say factor. Both have to be perfect squares. So if I look at number 1 right here, I've got n squared minus 25. N squared is a perfect square because I can square n to get n squared. And 25 is a perfect square because I can square 5 to get 25. And it is a difference. So I first like to write it like that. We have the n in parentheses squared minus the 5 in parentheses squared. And a difference of two squares will always factor into two binomials multiplied together. And whatever you're squaring to get that first term goes in the first spot in each binomial. So we're going to put an n there. And whatever I'm squaring to get this 25, which is my 5 that I put here, goes in the second spot in each binomial. And the only difference in the two binomials is one has to be a plus sign and one has to be a minus sign. And just one thing to point out, notice if I actually multiplied these two binomials together, okay, I'd have n times n, which is n squared, minus 5n plus 5n, and minus 25. Well, the minus 5n and plus 5n cancels out, and that's why we're only left with n squared minus 25. So the difference of two squares always factors into two binomials. First and second term are really the same in those two, other than the sign in the middle, or the sign on that second term, is different.